This is the rail network booking system for SOEN 342 over four. This is the rail network booking system for SOEN 342 over four iteration. I was able to build a complete software system with requirements, documents, UML diagram, formal specifications, database design, and comprehensive testing. Today, I'll walk you through each iteration to show the complete engineering process. So before going through the demo, let me show you the project structure first. Good. So here what you can see is we have a doc folder with requirements and specification. We also have a diagram folder with UML models, and we also have, of course, the Python source files for all the limitations and test files. So before I go over anything, here's what we built in total. I'm gonna echo everything. Good. So we have here 7 documentation files with 6 UML diagrams and over 4,000 lines of production code. And we also were able to run 44 automated tests. Let's see this in action. So first of all, the iteration 1 is the foundation. What we built is a route search system. This is, think of it like a searching for train tickets or a travel website. The system needs to find a direct route and also figure out connection with transfer. And the system really started by loading European routes from the CSV file that was given by the professor. Let me show you this. So here is the CSV that was given to us. What we see really is each line is one route with departure city, departure times, arrival times, train type of course, and days of operations, and also the pricing for the first and second class. On total, we have 1,200 routes total loaded from this file. Now let me search for direct trains from Amsterdam to Brussels. I'm using a command line interface with parameters, the CSV files, the same as the CSV files, departure time, arrival times, and limiting to 0 stop, which means that there is no stopping, only a direct route. That's what I meant here. Great, there we go. The system found the direct connections. You can see departure times, the arrival times, drive duration in minutes, and the price for second class tickets. The rightmost column showed a single leg from Amsterdam to Brussels. Now let us search really with one stop. Great, perfect. The system found 2 options. The first one is actually a direct route it discovered, but look at the second result. It shows one stop. You have a train from Paris to Amsterdam at 11:20, and we have arriving at 3:05. Then you have a 30-minute transfer times and to onboard another train from Amsterdam to Brussels at 15:35. And here the system really automatically calculates that there is 30 minutes gap and verify it's enough time to make really the transfer. Here we're going to talk about the second iteration. So what was really the second iteration is as the ability to actually book these trips. When you book, you need to transfer a travel information, generate Unix ID, and track while clients made which booking so they can actually view their trip history. I'm going to actually run a Python script that demonstrates the booking system. There we go. So what we have is we have here, yes, we have the search for connection from Amsterdam to Brussels, then book that trip. We have here 2 travelers. We have John and Jane. Each traveler has a passport and a number age. Let us run the code. Great. So booking successfully, the system generates a unique trip ID. You can see it's in alpha numerical strings in this iteration. Each of the traveler got their own tickets with a unique numerical ticket ID. And in the bottom, you can see the system can retrieve all trips from a system client by the last names and passport. Now let us go on the third iteration, database and validation. Iteration, what it really does is add two major features. First, the database persistence, so data survives when you restart the application. And the second is really, I would say, call it a small layer validation because you don't want to suggest a connection that makes someone wait for 4 hours. A train station at midnight, really. You don't want to make someone wait for 4 hours in midnight. So let us go initialize the database first. So this code create a SQL database. I'm using an in-memory one for the demo, but in production it would be a file on disk on our side. So what it does, it creates a table with the proper schema, then load the 1200 CSV from the database. Great. Let me let me explain first this one. In the 1200 routes here, loaded in database, just shows they have 5 tables: route, client, trips, trip legs, and tickets. All of them are initialized for now. Right now, only routes has data because it doesn't have truly data because we just initialize it. This is a normalized relationship schema with fragment keys and connecting everything together for data integrity. Now let us run a demonstrating the layover validation. Now the layover validation policy is the business rule is during daytime hours, a layover between 15 minutes and 2 hours is acceptable. But after hours, late nights or early morning, we can allow, let's say, 15 to 30 minutes because you don't want people stuck in the station. Great. So here what we have is that the first scenario, you arrive at 10 a.m. and your next train leaves at 11 p.m. That's a 60-minute daytime layover. The validator returns true. It's acceptable. And the second scenario is that you arrive at 11 p.m. and your next train leave at 11:45. That's a 45 after hour layover. The validator rejected this because simply layover is too long. And the reason is really explained why this prevents the system from suggesting unsafe and really uncomfortable connections. Now let us go with database backed booking with numerical ID. Now let me show you a complete booking that's persisted to database. This goes initialize the database, loads routes, creates the booking systems with database connections, and it actually also search for connections and books a trip for one traveler. Let me go in. Great. So here the traveler names is Alice. I call the Alice here, Alice demo. Trip ID with ID 1. Notice the trip ID here is now a simple number. That's because we're using the database auto incremental feature instead of generating random strings. Everything about this trip, the client records, the trip records, the legs of the trips, and the ticket is now stored in the database. And now let us talk about the final iteration. The final iteration was really to add formal specification to make business rules mathematically precise and really non-ambiguous. This includes OCF constraints and UML state machines that models the booking workflow as I would say an infinite state machine. Let me show you all the OCL constraint documents. Yeah, no problem. Great. So here, these are the constraints for the book trip method. Precondition, it says the connection can't be null, the traveler list can't be empty, and all ages must be non-negative. And you can't have multiple travelers in the same booking. These are checked before the method even run. This actually remove ambiguity. There is no guessing what valid inputs means. It's defined precisely. So now let us first show the demonstrate OCL constraint enforcement. Now I'll prove these constraints are actually enforced at runtime, not just documentation, of course. This code will, let me show you the code that will show us this. Okay, great. Great, so first booking a success and creates trip ID 1, but when we try to book Bob, test on the same connection, the system threw a value error exception. What does that mean is that the OCA constraint for preventing duplicate booking was enforced at runtime. And so the business rule is implementing the actual validation code. So here, let us show the show state machine diagrams. Now, let me really show you this model, the booking of what we said here. Great. So this is a plant UML syntax definition, the state machine. You can see state like idle, searching, display results, settling, all the others. Each arrow is a transition. A transition. For example, when you're in idle, you're gonna call start booking. You transition to searching. If connection are found, you move to display results. If not, you got errors. And so the last thing that we are going to do is let us show great. So we perfect. Started in idle state. After the search, moved to display results. After going through the booking flow, workflow, selecting connections, adding travelers, validation, and creation. It ended in displaying confirmation state. The trip was successful, created in 1, and this is the state machine.